Hello, Tom from Every Step Physics, EveryStepCalculus.com. This is a problem in physics regarding average angular acceleration, and I'm going to read it for you. An engine flywheel initially rotates counterclockwise at 5.75 rotations per second. Then, during 24.7 seconds, its rotation rate changes to 2.07 rotations per second, clockwise. We're going to define counterclockwise rotation as positive. That's what it gives us. So let's do it. Physics to get to my menu. I'm already at angular acceleration. Choose that. This just tells you that when you see rads per second, you're going to look for rads per second in my menu as well. Okay? We're after average angular acceleration in the problem. That's what it's asked for. And that's the change in angular velocity over the change in time. And we're going to put our variables in. We're going to press alpha first before we enter anything in these empty lines in my program. So we're going to choose alpha 5.75 revolutions per second. And the next revolutions per second is given as alpha. Since it's clockwise, it's got to be minus 2.07 revolutions per second. And the time is given as alpha 24.7 seconds. Number 2. The initial time is 0 then, okay? There's always an initial and a final time in these. And so we look and check this over and see if it's okay. It looks pretty good to me, so we're going to say it's okay. Number 1. We change revolutions per second to rads per second, okay, to get the angular velocity, initial angular velocity. And that's 5.75 times 2 pi equals 36.1 rads per second. Let's do the other one. The final one is minus 2.07. Turns out to be minus 13 rads per second. Now we put it together. Final less initial, and the time also, etc., here. The answer is minus 1.9893 rads per second squared. Pretty neat, huh? EveryStepPhysics.com. Go to my site, watch you buy my programs, and enjoy passing physics and doing these problems. How can you memorize this stuff? It's impossible to memorize this stuff, along with all the other stuff you have to memorize. Hey, have a good one.